Hi, in this video I'm going to talk about the anatomy of the cerebral cortex and try and give an understanding of the functions of each lobe and what lesions in each lobe might cause. So I'll start off with each of the lobes of the brain. So we have our frontal lobe, which sits at the front. We then have just behind it the parietal lobe. Then we have our temporal lobe, which you can only just see the inside of here, and our occipital lobe at the back. And those are the four main lobes of the brain. We do also have our insular lobe, which sits deep to our frontal and temporal lobes. And this I won't dwell on because the knowledge of its anatomy and its function is less important. And we also have our cingulate gyrus, which wraps around here and plays a role in the limbic system. So there are a few sulci and fissures that it's important to have an understanding of. So the longitudinal fissure runs directly from the middle at the front all the way to the back, and this separates the brain into its right and left parts. We next have our central sulcus, which separates our frontal lobe from our parietal lobe. So if you go about halfway back along the longitudinal fissure and then draw lines down the side of the head perpendicular to our longitudinal fissure, then this creates our central sulcus. We then have our lateral sulcus, which forms the superior part of our temporal lobe and separates it from our frontal lobe and our parietal lobe. And we have our parieto-occipital sulcus, which separates our parietal lobe from our occipital lobe. We also, within our occipital lobe, have our calcarine sulcus, which you can't see on this diagram as it's within the occipital lobe, but you can see on the diagram on the previous page. So first I'm going to talk about the anatomy of our frontal lobe. So we have our central sulcus running along here, separating it from our parietal lobe. And gyrus, where a gyrus is essentially a lump and a sulcus is a dip. So in front of this central dip, we have our first area that is raised. And this is called our precentral gyrus because it's in front of the central sulcus. And this is our primary motor cortex. So this is where most of our motor fibers that control how we move are found. In front of this, we have our premotor cortex or supplementary motor area. And in front of this, we have our frontal eye fields, which play a role in the movement of our eyes. On the inferior part of our frontal lobe, we have our Broca's area, and this can be found by going along our lateral fissure and following up the first significant indent. And this is called our ascending ramus, and this shows us where Broca's area is, and I'll come on to its function in a minute. We also have at the front our prefrontal cortex, and this forms the whole frontal portion. And at the bottom, there's a small area called the pars orbitalis. So what does our frontal lobe actually do? Well, we've said already we've got our primary motor cortex, but we've also got our prefrontal lobe. And this is important in helping us make decisions. And it's important in sometimes what's called executive function. So this is our knowing how to act socially and knowing what is and isn't acceptable, which means that lesions can lead to things like apathy and disinhibition. So you might be acting very unusually in social situations. And if it's in the motor part, it can cause motor weakness or loss. So next we have our parietal lobe. So if sitting in front of our central sulcus is our precentral gyrus, sitting just behind it is our postcentral gyrus, and this is called our primary somatosensory cortex, because our parietal lobe mostly is involved in sensation. And we then, behind that, have a supplementary sensory area, which also plays a role in sensation. At the posterior part of the parietal lobe, we have our posterior parietal cortex. And then we have these two gyri, which can be found. First, we have our supramarginal gyrus, which you find by following the lateral fissure all the way back until it reaches a gyrus in the parietal lobe. And this is called our supramarginal gyrus. And if you follow the superior temporal fissure, so this is the main sulcus or fissure running through the top of our temporal lobe, this will take you to another gyrus, and this one's called our angular gyrus. So what does our parietal lobe do? Well, we have a few important things. Firstly, we have the supplementary sensory area, which gives us something called stereognosis. And this is holding an object and being able to recognize what it is if you've got your eyes closed. So say, for example, you had your eyes closed and somebody passed keys into your hand, you'd be able to recognize from how they felt that these were a set of keys. However, if you have damage to your supplementary sensory area, you can lose this ability. Your posterior parietal cortex has input from your visual association cortex, and your supramarginal gyrus and your angular gyrus are important in language and understanding. So the supramarginal gyrus allows you to sort of understand and speak language, and your angular gyrus plays an important part in your ability to write and understand reading. So you can have problems with astereognosis, which is unable to recognize objects from touch, and alexia and agraphia, which are the inability to read and write. We also have something called body schema, and body schema is your awareness of your body parts in space. So this isn't to be confused with your proprioception. This is just sort of your knowledge that your body parts are there, as opposed to your knowledge of exactly where they are. So this is made up by your supplementary sensory area, your posterior parietal cortex, and your supramarginal gyrus. And if you have a lesion in this area, then it can lead to something called hemi-neglect. And this is essentially being unaware of your body parts within space. So this might be that you completely neglect the left-hand side of your body. So if somebody cuts their hair, for example, then it might be that they just don't cut the left-hand side of their hair because they aren't aware of that part of their body existing. So it's slightly confusing to get your head around. And you can test this by getting the person to draw a clock. And if they only draw one half or only put numbers on one half of the clock, then that can be a sign. Or if you ask them to draw a point directly in the middle of a line, then if they draw it too far to one side, then it's because they're basically not recognizing half of the line being there. So it's more common to get a left hemi-neglect than it is to get a right hemi-neglect. And this is because your right side attends to the left-hand side of your body, whereas both your left and right sides attend to the right-hand side of your body. So if you have a lesion on the right-hand side, you'll have a left hemi-neglect. But if you have a lesion on the left-hand side, then your right-hand side will still be able to give you some function, so you won't have this hemi-neglect. So now we move on to the temporal lobe. So in our temporal lobe, we have our primary auditory cortex, which sits just below our lateral fissure. And we have our Wernicke's area. So our Wernicke's area sits essentially around our primary auditory cortex. Next, we have our temporopolar area, which sits right at the front, and our inferotemporal cortex, which plays a role in visual association and sits inferiorly on the temporal lobe. We then have our fusiform gyrus, which is between our middle and inferior temporal gyrus. So our temporal lobe has a number of functions, including auditory functions, olfactory processing, and part of our visual pathway passes through, and this is called Meyer's loop. And this will be explained more in the video that explains the anatomy of the eye and visual pathway. We also have some sensory speech and language parts from our Wernicke's area, which I'll discuss more in a second. So we've mentioned our Broca's and Wernicke's area, and these play important parts in our language. So our Broca's area is often referred to as our motor speech area, and it sits in our frontal lobe. And if you have damage to it, then you lose your ability to have this motor speech function, so you can find it difficult to speak, and this is sometimes referred to as an expressive aphasia, in which your speech will be very slow and difficult. We also have Wernicke's area in our temporal gyrus, superior temporal gyrus, and this is referred to as our sensory speech area. And this, if you have damage to this area, then it means that you have a receptive aphasia. And this means that when you're speaking, you may be making up words and the sentences basically don't fit together and don't make any sense. But you won't be aware of this yourself, and you'll think that you're making perfect sense. So the Broca's and Wernicke's area typically have these functions on the dominant side of the brain, and on the non-dominant side of the brain, they'll have slightly different functions. And normally Broca's area is involved in the melodic aspects of speech. So if you have damage, it can be very monotonous, and your Wernicke's area can help you to comprehend other people's speaking, and that's why it's part of the sensory area. So we also have something called prosopagnosia, and this is where you're unable to recognize familiar faces. And this is another key function of the temporal lobe. So you'd normally expect to see a loved one or family member, and you can of course recognize their face. However, in prosopagnosia, you lose this ability, and you have to rely on other things such as the sound of their voice, or maybe even clothing that the people wear to work out who it is that you're speaking to. So this is made up predominantly from our fusiform gyrus, which has roles in face and body recognition and color processing. But as you're still able to recognize the voice and gait, this is how you understand who it is that you're speaking to. So the final lobe we're going to talk about is our occipital lobe, which sits at the posterior part of the brain. So we have our calcarine sulcus, and this is our primary visual cortex, and then we also have secondary and tertiary visual cortexes running just behind it. We also have the cuneus, and cuneus literally means wedge, and it's this area that's sort of wedge-shaped, formed by the parieto-occipital sulcus and the calcarine sulcus, and this plays an important role in visual association, and it's close to our posterior parietal cortex just here, which also plays a role in visual association. So we have information from our primary visual cortex, which receives and processes information, and from our cuneus, which does our basic visual processing, before passing it on to somewhere like the posterior parietal cortex. So hopefully that's helped to explain the basic anatomy of the cerebral cortex, and then you can fill that in with a bit more detail when you understand the other functions of the brain. Thank you very much.